This tutorial will be discussing the periodic properties and the trends of ionic radii versus atomic radii. So let's look at the cation first. As a small review, cations lose electrons and they're positively charged. So, if lithium has 3 electrons and 3 protons to begin with, and it becomes a lithium plus, so now we only have 2 electrons, one of the electrons have been removed from the atom. The result is a much smaller size. Cations are smaller than the atoms in which they came. The electron-proton attraction has increased, so the size decreases. Remember we had talked about the Z effective before. Well, that charge from the nucleus is being dispersed around the electrons. If there's fewer electrons there, that means that effective charge is going to be even greater on the electrons that are left over. So it kind of sucks it in. Z effective is the pull or the force an electron feels from the nucleus, which is the protons. The closer the electron is to the nucleus, the greater the pull on the electrons. The greater the Z effective, the more tightly the electrons are held and the more energy needed to remove the electrons. Electrons located furthest from the nucleus, or the valence electrons, have the least amount of the effective charge. However, once that electron leaves the atom, the remaining electrons feel more attraction to the middle, towards the nucleus, therefore pulling it even tighter. So let's do some comparisons. Look how much smaller lithium plus is from lithium. Or sodium plus is so much smaller than sodium. This is a trend throughout the periodic table, and it's all because those electrons are now feeling more of the charge of the nucleus. Let's reverse this and talk about anions, which are negatively charged particles. That means that they've gained electrons in this process. So, here's fluorine to begin with. We're going to add an electron to it. It actually grows even more than you would expect. Of course it's going to grow when you add more in there, but it's not for the reasons of it just having more stuff. It's because of the fact that the electron-proton attraction decreased, so the size increased. The anions are always larger than the atoms in which they came. Let's look at this slide again. The pull or the force of the electrons from the nucleus, or the protons. The furthest away the nucleus, the least amount of electron, the least amount of effective charge. The greater the Z effective, the more tightly the electrons are held. So if we add more electrons, if we consequently add more electrons, they feel less of the attraction because it's more spread out amongst the electrons. There's more charge to go around. So therefore the size increases because the Z effective decreases in the process. So look at how much it increases. This is far more than you could possibly think by just adding it. It's because of the charge in the center being not as great. The attraction is not as large. So let's do some comparisons. Sulfur is here. It's going from an S to an S2 minus. We're adding 2 electrons. Because we're adding 2 electrons, that makes this one larger. Calcium to calcium 2 plus. The positive means we remove 2 electrons. Therefore, this is going to be smaller, making this one larger. Make sure you read the question very carefully. It's asking for the larger one. Bromine minus versus krypton. That's hard because remember, those are two different elements. they actually have the same amount of electrons. 35 plus 1 is 36 electrons. And this question here is trying to reinforce the fact that it's not just the amount of electrons. It's the attraction between the positive and the negative that's actually causing the size change. Because there's a less attraction in the bromine, because there's fewer protons, the bromine minus 1 is bigger, is larger. FYI, 36 electrons, 36 electrons, those are the same amount. That is actually called isoelectronic. It's a series of elements or ions having the same electronic configuration. Same number of electrons, so therefore the same electronic configuration. So therefore, that's just its own little term there, is isoelectronic. Iso means same. But because of the fact that bromine only has 35 protons, the electrons don't feel the pull towards the electrons as much, towards the nucleus as much. Alright, and that is your explanation of the difference between atomic radii and ionic radii.